So with 2, 6, 2, 7, we're talking about rational functions. So we're talking about having something like a fraction. But what's happening is you actually have a polynomial on top and a polynomial on the bottom. So you have two equations, one on top, one on the bottom. So n of x and d of x for the function in the numerator, the function in the denominator. We're very concerned, right? What is that? We're very concerned about the domain because we don't want to create a zero, division by zero, so we can't have zero on the bottom. So that is the first thing we'll look at in a problem is what kind of restrictions do we have on our domain? So basically we'll take whatever's on the bottom, set it equal to 0 off to the side, and that'll tell us, pay attention to these numbers. One of the things that you might have picked up when you were in your Algebra 2 class is that any restriction on the domain would be a vertical asymptote unless the factor is in the numerator. So in other words, you found it to be a restricted number from the bottom, but if it also would make the top 0, or you see the same factor, then it's a hole in the graph, and we'll talk about that. We have some rules for horizontal asymptotes. Basically, you'll hear me talk, it's long-term behavior. So not what happens right away in the function, but what happens after a while. So our basic function you might be used to working with is y equals 1 over x. And its graph would look something like this. So when you look at that picture, you see that there's a horizontal asymptote on the x-axis, or y equals 0 line, and there seems to be a vertical asymptote on the y-axis, or the x equals 0 line. What's going to happen when I do 1 over x minus 1? What happens when you subtract inside the function? Which way does it go?
Right.
Opposite, so it's going to the right 1. So what that's going to do is move my vertical asymptote to the right 1. My horizontal will not move at all, so that will still be here at a height of 0, so y equals 0. And then the graph would sit in this corner, in this corner. So the two questions I ask you are, where is your vertical asymptote? Well, that's at x equals 1, and your horizontal is at y equals 0. What happens when I plug x is 0? What happens when x is 0? To be a little more accurate, I get 0, negative 1. So for more accuracy, I should have probably brought my graph up right there. So on this test, that's really the big key to this thing, is find horizontal, vertical asymptotes so that you can actually see the behavior, and then you would find intercepts, which is at the end of a pre-calc course, we should all be very good at doing that. So let's just double check on the calculator what's going to happen. So let's go back to mode. If you haven't changed back, we want to get into function mode, so it's y equals. Like I said, if I did 1 divided by x, zoom 6 standard, that's what our graph would look like. Now we did 1 over x, and when you do these, you're going to have to go to parentheses, x minus 1. Now, depending again which calculator you're using, some of them will actually draw a little kind of spiked line in there because the earlier programming in those calculators, they didn't know how to handle asymptotes, vertical asymptotes, how close could it get. So there is no line there. So you can see the imaginary lines, and that's really what we're going to study today is where do they all come from. All right. Horizontal asymptote rules, right here. If n is smaller than m, and what they're talking about is m is the degree of the denominator, n is the degree of the numerator, right? So what happens when the bottom of the fraction grows faster than the top? What happens when the number on the bottom of a fraction keeps getting larger and the top one doesn't get as big? What happens to the number? It gets smaller, 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 right? So anytime the bottom is the big number, and again, what's degree? Degree of a polynomial is degree. The largest exponent within a polynomial. So we should have it written in that descending order. So always look for the largest one. And you may hear me refer to it as small over big. If the degree on top is small, the degree on the bottom is big, this thing is going to 0. If the degrees are equal, that's what this rule is. I just simply refer to that as the leading coefficient rule. What's a coefficient? The number in front of the variable. What's the leading coefficient? It's the number in front of the variable that has the highest exponent. So if you look at it and nobody has ordered it correctly, grab the term that has the highest exponent, write it out front, and that number is called the leading coefficient. So if the degrees are equal, you just take the leading coefficients and you divide them. It'll be y equals that number. And here's the one that I said when you decide to get in your groups, make sure somebody can do polynomial long division. If it's the big number on top and the small number on the bottom, so degree, when you look at the degree, if it's big degree over small degree, what happens when the number on top of a fraction continues to get larger than the number on the bottom? The value gets bigger and bigger and bigger. So nothing's controlling it. It would just continue to rise or in the negative direction maybe go down forever. So it's called a slant asymptote. It would never level off. Then you have to use your polynomial long division to get your answer. So let's start by looking at this first problem. You might grab x plus 1. Well, let's grab x plus 1, set it equal to 0. So take the denominator, set it equal to 0. Right now it's telling me that -1 would be a restriction on the domain. Now, is there any factoring that I can do on top? That would, okay, so we don't have to worry about that. So let's go to -1 and put in, we'll put in the vertical asymptote. Next, you might do the horizontal asymptote. So what's the degree on top? It's x to the first, so it's a first degree on top. What's the degree on the bottom? Also a 1, so it's a first degree. So what do you do when it's first degree over first degree? Go to the leading coefficient. Well, what's in front of the x? What's in front of the x on the bottom? You need to write it in there to remind yourself it's 1x, not 0x. If there's a 0 there, the x1 would be there itself. So it's 5 over 1 or 5. So on your graph, you go 1, 2, 3, 4, 5. So y equals 5 is a horizontal line. Now it's just a matter of, what happens when I plug in 0, by the way? If x is 0? you plug in 0 on the bottom, you get 1. And 5 times 0 is 0, so 0 divided by 1 is 0. So I have an intercept of 0, 0. Which kind of helps you determine where the graph is located. So those of you with your calculators out, if you're typing it in, you might put 5x in parentheses divided by x plus 1. But you should be able to tell us here, right? And my guess is it's over here, right? Somebody that graphed it can verify that for us. And that's what you have to do these problems. Find vertical asymptotes, find horizontal asymptotes, any intercepts.
These look familiar.
Well, we've done them before.